Again, my suggestion would be to have your own paper and try to work the problems once I've explained them. So listen to me explain it, and then you try to go back without looking at my work and see if you can work the same thing. So in question 5, we are looking for an equation of a line that passes through this given point, and they're telling me it's perpendicular to this other line. Now, before we can do anything about the slope, we have to come over here and find what the slope is. So this is actually the first step of this problem. So remember, on slope, you're taking your y2 value, which is 6. You're subtracting your y1 value, which is 4. Then you're taking your x2 value, which is 2, and subtracting your x1. So, which is the 0. So 6 minus 4 gave me 2. 2 minus 0 is 2. And when I reduce it, I get a slope of 1. Now, we are looking for a line perpendicular to that. So you have to remember that perpendicular lines have opposite reciprocal slopes. So perpendicular lines, when they say that, they have opposite reciprocal slopes. So the opposite of positive 1 would be negative 1, and the reciprocal of 1 is still 1. So that's the only number that when you flip it over, it's still itself. For example, if my slope had been 2, the reciprocal of 2 would be 1 over 2, and then I would also have to make it opposite, so it would be negative 1 over 2. But in this case, as I mentioned, my slope for my line is going to be negative 1. So going into my y equals mx plus b format here, I'm going to take the y value of 8 for the point they gave me and plug that in. My slope that for the perpendicular line is negative 1. The x value for the point they gave me is negative 4, and I'm looking for my b. So I get this equation here where 8 is equal to 4 plus b, and if I subtract 4 on both sides, then my b value is 4. So my final equation of this line would be y equals a negative x plus 4. Okay, this next one is a word problem. So the first thing you want to do is translate what they've told us into points. And so basically, if I look right here, there were 16.6, and that's millions of employees in 2005. And they go ahead and tell you that let x equal 5 represent that year. So here's my first ordered pair, where x is 5 and employees is 16.6. And then notice they tell me that in 2014, I had 18.6 employees. So this would be a second ordered pair. So this is nothing more than just a problem where they're asking me to first find the equation of a line. So again, I did my slope formula. So I would turn the video off and see if you can do that on your own. Decimals are okay here since they're using decimals in the ordered pair. So while I do get a slope of 2 over 9, I'm going to change it to the decimal of 0.22 since they're asking for you to round to the nearest hundredth. And again, once you have your slope, that's when you come in to the equation y equals mx plus b, plug in one of your points. So I happen to, in this case, I decided that I was going to plug in the 16.6 for my y. My slope is the 0.22, and then I have to make sure that I plug in 5 for my x so that I'm getting both x and y from the same ordered pair. So in this case, when I multiply 0.22 times 5, I get 1.1. When I subtract that on both sides, I'm left with a b value of 15.5. So that led me to this equation where my y was equal to 0.22x plus 15.50. They said round to the nearest hundredth, so that's 2 decimal places. And then they asked me a second question. They asked me about the year 2011. So if we're talking about 2011, x would have to be equal to 11. So using the equation that I just found, I'm plugging that x value in, simply getting on a calculator to punch it out, and I get a y value that would give me 17.92 million. Okay, on question 7, remember you have to show work when you're working these on your paper for the final. And so in a case where I have a square root, the way we find the domain is we always take whatever is under that square root and we say it must be greater than or equal to 0. And that's as long as the square root is not in the bottom of a fraction. If it were in the bottom, then you certainly wouldn't say equal to 0. But in this case, you do. And then you simply solve. Now, I'm reminding you of a special rule here. So notice I went ahead and subtracted 8 on both sides. So that's how I got the negative 8 over here. And the special rule, so if I'm trying to get rid of this, what's understood to be a negative 1 in front of the x, the special rule says anytime you multiply or divide an inequality by a negative, you have to flip the symbol. So notice my greater than or equal to flipped around and became less than or equal to. And then, of course, negative 8 divided by negative 1 is positive 8. Now, I always like to draw a number line just because it's easier to get your interval off of that. So since it could be equal to 8, it's a solid point. That's going to indicate on your interval that you have a square bracket. And then everything is shaded to the left. And so when it keeps going, we call that negative infinity. And because we are touching the actual 8, that's why on our answer choice, you would have the actual square bracket. On the next question, when you're doing domain with a fraction, what we know is that the bottom of a fraction cannot equal 0. So you take whatever's on the bottom and you say cannot equal 0 and then simply solve it. So if I subtract 4 on both sides, I'm finding that x cannot be negative 4. So on a number line, there would be a big hole in the graph, and then everything to the left and right would be shaded because you're saying x can be anything except that value. So basically, you get two intervals here. You're getting an interval that starts at negative infinity because of that arrow, it keeps going, and it stops close to 4, but it doesn't touch 4 because there's a hole there. And then we say it starts again close to, not 4, but negative 4. On the right-hand side, again, it doesn't touch it, so we're using parentheses, and then it keeps going to positive infinity. So make sure, be very careful on your answer choices. You do not want the square brackets on this particular interval because we're not touching negative 4.